Now let's study how to use SPSS to run a decision tree model. At the moment, our ultimate goal is to make this kind of tree using SPSS, but later to interpret the outcomes or to understand the tree structure, let me briefly explain some terms or the structure. First, we will start with the root node or the node number 0 here. So this is nothing but the frequency table of the variable bought. So out of 10 customers, 3 of them bought Greek yogurt versus 7 of them did not purchase Greek yogurt. We split this root node later. So in that case, the previous node is called parent node, and then the new nodes, as a result of splitting, they are called child node. In this case, node 1 here and node 2 are the labels. So again, before splitting, parent node, after splitting, child node. Definitely, we can split a certain node, in this case node 1, further. In this case, then node 1 is called parent node, and then as a result of splitting node 1, we will get node 3 and node 4. And these two are child node, like this. So again, before splitting a certain node, parent node. As a result, we will get child nodes. However, in this case, node 2, there is no further splitting. Then this is kind of the final node. And actually, if you see the whole structure or tree, you will realize that after node 2, node 3, and node 4, there is no further splitting. Therefore, we say that final nodes are number 2, 3, and 4. In terms of marketing terms, we can call them segments. So from now, let's start to make a tree. Click on Analyze, and then Classify and Tree. So this is the path to run a decision tree model. Then here you need to move the variables. First, let's choose our y variable, but move it to dependent variable, and choose the other variables, x variables, gender, marital status, and income level, to independent variables. Please make sure that among different growing methods, choose CRT, which stands for classification and regression trees. It is important because if you choose a different method, then you will see a little bit different outcomes. Only if you choose CRT, you can also get the importance of variable table. And then you need to select some options. Let's click on output first. Then here, among these tabs, click on statistics. And then in this box, independent variables, click on importance to model. Using this option, you can understand which variables are more or less important to explain the y variable. Continue. So far, so good, but in our case, there are only 10 observations. Actually, it is kind of weird to classify 10 customers into several groups, but it is still possible. However, because we have only 10 observations, we need to adjust some numbers, especially maximum tree depth. So here depth means, in our example, the number of layers after the root node. In this case, the depth level is 2, 1, 2. The current option is automatic, but because we have only 10 observations, let's customize the number. So let's say we want to select the number 3. So up to 3 levels of depth. Another one you may want to do is minimum number of cases. So here, as a result, it means that as a result, there should be at least 100 observations in the parent node. And if there are more than 100 observations in a node, then the decision tree algorithm tries to split the node. And as a result, the number of observation in the child node, should be about 50 or at least 50. But in our case, there are only 10. So we need to reduce this number. So let's simply say 3 and 1. That means if there are 3 observations in a certain node, then I request as the algorithm to split the node, and as a result, there should be at least 1 observation in a child node. Later, we will learn more, but if you reduce the number of cases in the parent node and child node, then you will have a larger tree. And if you increase these numbers, then you will have a smaller tree. So let's just continue. So to have a kind of large tree, and then click OK. Now you can see the model summary table, and this is the main result, node 0, 1, 2, 3, 4, which I explained the structure and the terms like a parent node versus child node. And in this case, node 1 can be a parent node, and as a result, we will get node 3 and 4 as a child node. Later, I will explain classification, like prediction classification. This one just shows the count in a cross tabulation between observed bot variable versus predicted bot variable. And I will explain this one later in detail. But here, let's focus on this table, independent variable importance. So we used 3 variables, income level, marital status, and gender. And according to the algorithm, income level is the most important, and importance is 0.270, followed by marital status 0.15 and gender 0.077. These numbers are actually the Gini index improvement after using a certain variable, which is the I will briefly explain the concept, but kind of out of scope of this class. But just remember that importance means Gini index improvement. This table also shows the normalized importance. Say, let's set this number 0.270 to 100%, then you can get the kind of relative importance level. So that means 55% means 0.150 divided by 0.270. So if we think that income level is important, like 100%, then the importance of marital status is half of the importance of income level, etc. Now, if I briefly explain the splitting rules, again, this one, node 0, is the the frequency table of the variable bot, and we look and let's just assume that in this node all the observations are kind of located, and then we kind of split this node in terms of income level, and then one segment has the income level of average, and the other one has the income level of high or low. So in the original data set there are 10, but in the first node 1, there are only 4, but the purchase rate is 75%, which is much larger than the total data purchase rate, which is 30%. So just by using one variable, income level in this case, we can find some segment, or in this case a segment, which shows a higher purchase rate than the total rate. In case of node 2, there are 6 people, and as you can see here, the percentage of purchase is 0. So none of them purchased Greek yogurt in this segment. Next, we can split node 1 in terms of marital status. So then we have married versus single divorced groups. Then let's characterize node 3. This node or segment shows you need to look at the first depth first. So this segment means that the income level is average, and then marital status is married. How about node 4? Income level is average, and then marital status is single or divorced. So we can characterize each segment or node by using the splitting variables and categories. After you finish interpretation, interpreting the main table and the importance, then you can save some predicted outcomes. So let's go back to our data. Then let's click again, like analyze, classify, and treat. You don't need to change anything, but this time we are going to save some new variables. Here you can save terminal node number 1 through 4 in our case. Predicted value, that means yes or no. And then let's skip predicted probabilities, and then click OK, and continue, and OK. Now you will have the same outcomes here, but if you go to your data, you can see that two variables are newly created. To understand them, let's click on Variable View tab, and you can find the meaning of each variable. Node ID means terminal node identifier. That means, as we can see in the tree, there are 3 terminal nodes. That means no further splitting after the current node. So we have node 2, node 3, and node 4 based on the characteristics of the consumers in terms of income level and marital status. For example, in case of node 2, if their income level is high or low, regardless of marital status, they fall into this segment, node 2. In case of node 4, if income level is average and marital status is single or divorced, then people would fall into this category or segment. And this variable node ID shows the predicted segment based on marital status, income level, and gender, even though gender is not in this tree. The second variable is predicted value. That means whether they would purchase or not. In this simple case, the predicted values are the same as the actual values, but in many cases, these numbers are kind of different. So this is, again, this variable node ID is kind of the segment number, and this variable is determined by looking at gender, marital status, and income level, but in our tree, gender is not used, so marital status and income level. So depending on the conditions or the categories or characteristics of consumers, we can find the predicted node ID. For example, the first observation has the income level of high. So income level high, therefore this person or any person with this characteristic would fall into node 2. How about the last one? Marital status is single and income level is average. So income average, marital status single, therefore this person will fall into node 4. And according to the prediction, like this. So we can easily understand who falls into which segment. This is the predicted value. We can kind of make a prediction classification, or we can calculate the classification ratio. So in this case, we use cross tabulation because we are going to examine the relationship between bot, actual bot, and predicted bot, these two. So click Analyze, Descriptive Statistics, and cross tabulations. Then let's reset. Here, we move bot into row. That is kind of different setting. And then we move predicted bot to column. And then don't forget to click row percentages like this. Continue and then press OK. Now we have this table, which is the same as this table from the decision tree outcome. And I'm going to explain how to interpret this table. In our PowerPoint, this is the result from the decision tree, but here there are counts only. It would be a little bit difficult to interpret, so we are going to use this one. As I did in other cross tabulations, we need to interpret the table row by row like this. But first, we check the total number of observations, 10, and actual no is 7. And out of these 7, according to the decision tree, because it is kind of artificial data set, the predicted value no is 100%. That means the prediction is 100% correct. How about bought? Yes. There are 3 customers who bought Greek yogurt, and based on our classification, predicted outcome is all of them will be yes. That means they will bought. So actual bought and predicted bought. So 100%. So the correction rate is also 100%. Therefore, based on these these numbers, we can calculate the correct classification ratio and misclassification ratio. That is the correct classification. Let's find correct classification first. So actual no, predicted no. This is the correct classification. So 7. Actual yes and predicted yes. 3. So 7 plus 3 divided by the total number 10 is 100%. So correct classification ratio is 100% in this simple data set. By the way, how about misclassification ratio? That means actually it was no, but if it was predicted to be yes, then it is misclassified. So the number is 0. Actual but is yes, but if it is predicted to be no, like this one, then it is also misclassified. So in this case, we add 0 plus 0, which is 0, divided by 10 is 0%. Again, because this data is too simple, we have like 100% correct classification ratio or prediction accuracy. But in reality, this case is very rare. It would be like, for example, 30% or 70%, etc. We will practice a little bit dirty data later. Lastly, I'm going to briefly explain impurity and Gini index. Gini index means we want to kind of know which variable is more important than less other important. As we saw the table, importance to model table. And if the concept is too statistical, so you may want to skip if you cannot follow the instruction. So let me briefly explain. Let's assume that in the layer 1 and 2, or parent node and child node, we can calculate the probability that y is equal to 1 and y is equal to 0, like purchase or no purchase, something like that. And let's assume that there are 10 customers, the same as in our example. Then probability of y is equal to 1 is 0.3, the same as our example. And the probability of y is equal to 0 is 0.7, and we denote them by P and Q. And using the other variable income, we can kind of split the whole data. And then now there are 4 people in this segment. And in this case, P is 0.75 and Q is 0.25. Like there are more people who purchased Greek yogurt. In the other side, there are 6 people, and here the P is 0 and Q is 1. That means none of them purchased Greek yogurt. In this case, we can calculate purity or impurity, but the term pure means if all data points associated with the node have the same value, something like this. All of them did not purchase Greek yogurt, the same value of the dependent variable. So this is pure and this is not pure, and this is not pure either. Then how can we quantify the purity or impurity? We will use Gini index or in other words impurity measure. So this is the weighted average of P and Q, especially 1 minus P squared minus Q squared, and the lower the better, or the purer. And now let's take a look at the calculation logic. In layer 1, I'm going to erase the point. The Gini index is calculated by 1 minus 0.3, that is this probability, minus 0.3 squared minus 0.7 squared. That is 0.432. In the second layer, the combination of this node and this node. So the first one is the Gini index is 1 minus 0.75 squared, this number, minus 0.25 squared, this number. From this node, we can calculate this Gini index. By the way, in this layer or depth, there are 4 people in the first node, and there are 6 people in the second node, so we need to kind of put a weight. Then the Gini index for the layer 2 is 0.15. So this again, Gini index shows the impurity level, and we can see that in the second layer, by splitting the entire group in terms of income, we get the purer outcome from 0.43 to 0.15. Therefore, the Gini index improvement is 0.27. And this number is associated with the importance of each variable. So this is the way we calculate Gini index. But again, if it is too statistical, you can skip this page.